Hello, I'm Dr. Papia Bhattacharjee. In this problem, we have a function and that represents a cost function. The cost of producing, say, X unit of a product is given right here. We have to find the number of units X that will minimize, not the cost, but it will minimize the average cost per unit, which is denoted by C bar. So, to start the problem, let me first remind you what is C bar. The average cost per unit is determined by, you take this cost function C and divide by X. So what we have to do, we have to figure out when will this be minimum, for which, how many X, what is the number of units. So we have to minimize C bar and figure out which X will do it. All right. Let me also remind you what is the concept behind minimizing a function. So say you have a continuous function f and it has a minimum point. So at that point the function has a minimum value. What happens right there? Notice that if you draw a tangent line to the curve, at that point you get a horizontal line. And because the line is horizontal, the tangent line is horizontal, the slope of the tangent line will be 0. Now, what is the slope of tangent line of a curve or of a function represent? It's nothing but the derivative of that function. So, the derivative will be 0 when the function reaches a minimum point. So, that's the concept that we will use to figure out when is C bar minimum. All right. So, we need to take the derivative of C bar. So, let me rewrite what C bar is first. Like I said, it is C over X and C is given right here. C is 0.125 x squared plus 20x plus 5,000 and divide the whole thing by X. Now we can take the derivative directly from here by using quotient rule and so on, or we can simplify this expression first and then compute the derivative. So let's try that. So see, we are going to divide everything by X. We can divide each of these functions by X separately. So the first one will be 0.125 x squared over X. So that is just X. Then we'll have 20 x over X, just 1. So no more X for that one. And then 5,000 doesn't have any X, so it will have an X in the denominator. So you're dividing each of these terms by X. Now I want to rewrite this one more time. So 0.125x plus 20 plus this last term, I want to write it as 5,000 and 1 over x is x to the power negative 1. The reason I wrote it this way so that I can take the derivative easily. All right, so this is our function C bar. And now I have to take the derivative, set it equal to 0 and figure out the minimum point. So let's take the derivative. What is d dx of C bar? And that is d dx of this whole expression, 0.125x plus 20 plus 5,000 x to the negative 1. All right, let's compute that. First one is 0.125 and the derivative of x is just 1. Derivative of 20 is 0, it's a constant. And then you have 5,000, derivative of x to the negative 1 using the power rule is -1 x to the -2. So that is our derivative. All right. So let me rewrite it. So we have 0.125, and then the 0 will just go away, and the 5,000, this last term has a -1, so it will be -5,000, and then x to the -2, I'm going to bring it to the denominator as x squared. So that's the simplified form of the derivative. And now to minimize the function, we set this equal to 0. So to minimize, set dc bar dx equal to 0, which means 0.125 minus 5,000 over x squared is 0. And then you have to solve for x. So bring the second term on the right hand side. And then we have to solve for x. So bring the x squared on the left. So we have x squared is equal to 5,000 over 0.125. Okay, so let's calculate that using our calculator. So what is 5,000 divided by 0.125? That is 40,000. But this is x squared. So what is x? X is plus or minus square root of it. And so that is 200. All right. So we got some x value, and there are two x values actually. So how do we know that x equals positive 200 will correspond to the minimum value of the function? Because notice that if a function has a maximum point, same thing happens. The derivative is 0 there. So how do we know that this will give us minimum and say not the maximum value? So the best way to check that is graph our function and look at the graph and see if we really are getting a minimum value. So pick your graphing utility and then let's graph C bar. So plug in y equals right here 0.125x plus 20 plus 5,000 x to the -1 and graph it. But note that you have to be careful about the window. See, x value is 200. So let's make the window say x from -300 to 300. So you can see the graph, the whole graph better with a scale of 10. And same for y, so -300 to 300, scale 10 and then graph it. Okay, now use trace function and plug in x equals 200. And look, y is 70 and we get that point is the minimum for this graph. So using the graphing utility, we confirm that x equals 200 will give us the minimum C bar. So let me write that down. So 200 units will give minimum. And C bar is average cost per unit. So that solves the problem. Thank you.